In the last few years, swinging has been everywhere. From games to movies, swinging, especially when done by everybody's favorite webhead, has been a repeating theme in major media. Why was swinging so popular though? Because it's awesome. Look at it. So today, we're going to make a Spider-Man game in Unity. Not. We're just going to make a simple 3D swinging game. Nope. Still not it. Today we're going to get started with swinging mechanics by learning how to use the HingeJoint2D in Unity. Basically, the HingeJoint2D is a rigid body 2D modifier, so it gives more functionality to the standard rigid body 2D. So with it, you can make pretty standard things like swings or doors, or you can make cooler stuff like merry-go-rounds or other things.
A potato flew around.
Alright, so let's dive right in and get something working in the editor. So first we're going to make a physics ball. Then we're going to add its hinge joint component. It already has a rigid body. We're going to turn off its auto-configure connected anchor and translate its anchor up by 3 units. Now when we hit play, if we add a little sideways force, we already have a working swinging ball. I'm going to start it again and I'm going to move the anchor. I'll move it to 0, 3. We'll see that immediately this line becomes longer. Or it didn't even have length, and now it does. It had length of 0, now it has length of 3, which is, well, that makes sense. Now, I'm going to change my anchor to 3 on the Y, just like we had it before, and 3 on the X. And you'll see that this point, this green circle with the blue circle inside, which signifies where the anchor is, moved. It was 3 units above the ball, and now it's 3 units above the ball and to the right of the ball, and we have this green line, which could be mistaken for the hypotenuse of a triangle, which is basically what it is. So at 3, 3 it's there, or at 3, 0 it's there, and at 3, 3 it's there. And this green line when it's at 3, 3 is longer than when it's at 3, 0. So why are we learning trig? Because the anchor is basically the displacement away from the connected anchor. Yeah, so at 3, 3, this line is longer than when it is at 3, 0. Now another interesting thing, but this one's pretty straightforward, is the connected anchor. Basically, it's the other end of the hinge in world space. So this point I'm zooming in on with the scene view, well, the anchor's there now, but underneath it there's another point, and if I move the connected anchor, we'll see that the whole thing moves. So it moves in world space, so it makes sense. And we'll see that this hinge joint is maintaining the distance of whatever the length of this imaginary triangle is. Okay, so now let's look at the use motor property and figure out how this joint motor works, which is what it's called. So we'll hit play and we'll see what happens. I'll turn on use motor, and it immediately gets stuck. Now, if I set maximum motor force to 0, it keeps rotating as usual, but if I set it to something like 100, it'll stop rotating mostly. Now, the reason why this is, instead of just spinning around like you would expect it to, is because our motor speed is 0. So if I set this to 10,000 and I set my motor speed to 90, it'll rotate jerkily. So if I up that, it gets smoother. And yeah, if you want really just smooth rotation, just set it to mathf.infinity and it'll rotate smoothly. Now how fast is it rotating? 90 degrees per second. So if I set this anchor back to this x property to 0, it'll get shorter and it will continue rotating at 90 degrees per second. So motor speed is in degrees per second. 360, 1 rotation per second. So also it naturally spins to the right. If I make it negative, it'll spin to the left. Just overlook that, set it to negative 360. and it spins to the left. Okay, now we're going to look at angle limits and kind of make like a swinging door that has limits. So if I turn on angle limits, and also, real quick, let's look at auto configure connected anchor. So right now, auto configure connected anchor is on because it's on by default, and this is a new hinge joint, and it's here. But like, why is it here? It's because that's where the object is. So it sets it by default to the position of the object plus a transform that's based on the anchor. But because the anchor is 0, the transform is 0, and it's directly where the object is. But if I change this anchor to negative 0.5, which is the top left corner, we'll see that the connected anchor and the position are not the same anymore. And they have been scaled based on the scale of the object and the anchor. So it's like they multiply it together and add it to the position, and that's where the connected anchor is when you have auto configure connected anchor on. And the reason they do that is because it makes it really convenient to make things really simple, because when I make something like this, when I hit play, it's going to rotate from the gizmo that I see on the screen. So when I hit play, instead of moving, it's going to rotate directly from where I saw it. So it's pretty convenient. We'll just leave that on and turn on use limits. So limits give it like a maximum and minimum rotation. So if I decrease the upper angle, it lowers its range of motion to here, to about 90. Now it can only rotate 90 degrees. So it's pretty simple. It rotates in the green. So to show you that, I will change this again. But now the box isn't in the green. But when it starts, it'll just move itself so that it is in the green. Anyway, now let's combine our knowledge and make something cool with the limits and the motor and everything else we've learned. So we'll leave this anchor in the corner of the object, and we'll reset our limits to 0, 360. And what we want to do is we want to make a revolving door that's going to just rotate open and shut based on what direction the motor speed is. So what I'm going to do is leave my upper angle there, but increase my lower angle to 180. So now it stays within this green area. Now turn on use motor, change my speed to negative 90 because I want it to rotate to the left, and change its motor force to say 50, then I'll hit play. Alright, wrong direction, positive 90, negative 90, and so forth. So we see that it's just creating like a door-like hinge, which can be really useful for making doors in games. Another cool thing that you could do with this potentially is if you had like a physics-based game, you could have this maximum motor force be much lower, like 5 or something. So the door would close slowly, but it would make sure that it stays closed. So the player could walk through it, and the door would still eventually close. Okay, now we're going to look at connected rigid body, enable collision, and brake force. Yeah, and brake torque is self-explanatory once we look at brake torque. So connected rigid body requires another rigid body, which is what this square is. So we're just going to drag it in to fill that. We'll see that the connected anchor changed. Now the connected anchor is not this position, the position of this box, or the position of this box. It is the position of this box with regards to the local space of this box. So when I move this box up to 0, we'll see that the connected anchor, when their positions are overlapping, the connected anchor is 0 because it's displaced or transformed by about 0 away from its connected rigid body. So when I start or play, the anchor is also at 0, 0 right now, so it's in the center, and it's just spinning around its center, which is alright, but that's not really what we're going for. So normally, when you have a connected rigid body, now your anchor is going to be where it spins around. So if I put my anchor over here, the side, it's going to spin around this point. Let's stop if I put my anchor right here. It's going to spin around that point. Now let's look at enable collision. Enable collision is collision with the connected rigid body. By default, it's off. So it's going, you can see it rotating through that rigid body even though they both have colliders and rigid bodies. If I turn it on, it hits. Turn it off, it doesn't. Okay, the last thing we have to look at is brake force. Yeah, and brake torque is just like brake force, except it's torque. So it's a maximum amount of torque before the joint breaks. Brake force is the maximum amount of force you can have on the joint before the joint breaks. So I have set it to 100. I have a script that will add force when I hit space. When I hit space, it adds a force of 10. And I'm going to hit it now, and we'll see that the joint breaks. So yeah, that could be useful in certain like physics-based games. Anyway, that's it for the hinge joint. So thank you for watching this video, and I hope you learned.